I'm sorry for the cutoff on the last video. I thought my application had given me unlimited recording, but for some reason it didn't. Um, Anyways, looking at this, this may look a little bit familiar. We're looking at the different games in the series and different possibilities, and overall which team would win the pennant. This is exactly what we did during class, and we saw that we ended up with something that looked like this, with maybe a couple ties in here, and then an overall loss over there. Oh, I forgot one win. And we can use this area model then to calculate a certain probability of a team winning the entire pennant, right? So you may want to check out those notes from last time. I should post. There should be a screenshot posted in our Google Classroom, and you'll be able to check out what we did on this assignment. But this was also referred to as an area model. A little note here is that I personally, I typically use an area model when comparing or using two events or possible scenarios. So in this case, we only have two teams, so I would maybe use an area model to help me figure this out. It's really easy because then you can just come down each row and each column, or each row and each column, and make a decision using probability and calculate something given that it has two different events or scenarios. This is when I would use an area model. It helps me visualize what's going on and the different possibilities of something actually happening. We'll do some more work with area models once we get back to class. One of my favorite things to do, and I still do it to this day, is actually something called a tree diagram. And for those of you that saw me start writing in lowercase, I apologize. I need some continuity in here. Tree diagram. A tree diagram you may have also seen somewhere in your past. However, tree diagrams are used to typically calculate probability. Actually, I'm going to say display probabilities. And I like to use the word chains. Probability chains. What I mean by that is we typically use a tree diagram when events occur in sequence. We use tree diagrams to then track those events. And to track event outcomes. So let's go do an example from the book, and it's actually the one that we talked about in class together with the activity, how likely to win all 7 games? And I want to use the probability that the good guys are going to win all 7. So when we're doing a tree diagram, everybody has to start somewhere. And if the good guys are going to play in their first game, I'm going to put a little circle here. I want to put game 1. There's 2 things that can happen. 1, they can win that game, or 2, they can lose that game. Now, to most of us, a tree diagram may look like a bracket, like a playoff bracket. It follows the exact same logic, okay? So given a win or a loss, this person would then experience the second game. So after this, they would play game 2. I'm going to put game 2 down here because now it's broken up into 2 different games, which means they can either go from this game and they can win this game, or they can lose this game. And so if you check it out here, we're going into all these different scenarios looking at, hey, what's going to happen with this tree diagram? And actually, when we look at this tree diagram, what I should do is I should erase these ones because we start somewhere. These would be your outcomes for game 1. These would be your outcomes for game 2, your potential game 2s.